All right, hello everyone. Wow, I didn't even start, but I guess Tim really spoiled some of it, which is a good thing, because we are going to see some amazing configurations and some amazing things that you can do with Swift and Swift PM today. So, hi everyone, I'm Kabir, and a few things about me, since I realize that a lot of people here don't know who I am. I am studying computer science at the University of Waterloo. I hear we have a few more Waterloo people here. Can we have some noise for Waterloo? Woo! Yeah. I am also currently working as an iOS developer at Ramp. In fact, JP, who's also speaking, is also an iOS developer at Ramp. I want to make it very clear that none of the cursed stuff I'm showing here is endorsed by Ramp. But yeah, I mean, some of it is fun. So I'm also a maintainer on the open source Theos build system. And this is something that we actually used in the jailbreak community back in the day. And with Theos, it's make-based, and you can basically target any platform on any OS. And that's where a lot of the experience for this talk comes from. So I'm not particularly going to be calling out to Theos in this talk, but I would highly recommend, if you're interested in that sort of thing, you should check it out. OK, time to get a little bit meta. So I was looking for some statistics for this talk, and I saw this graph in the Stack Overflow 2023 developer survey. So it asks, which frameworks and libraries have you done extensive development with over the past year, and which ones do you want to work with over the next year, right? So you can see that these nodes are basically connections between what people have worked on and what people want to work on, right? And I saw something really interesting here, which is that with SwiftUI, there seems to be a visual glitch, right? Like, there's just that little pointy spoke there. What does that mean? Did Stack Overflow mess up their JavaScript or something? No, it turns out that we just love SwiftUI so much that it's the only thing we want to work with. But that's also kind of interesting, right? Because it shows that people who use SwiftUI really love it, and people who use Swift as a language really love it. People in other communities don't really know about all of the great things that we have to offer. And one more statistic here, right? So this is the question, which programming languages, again, the same question, basically, but with a different graph. And it shows what languages people admire and desire. And a lot of people admire Swift. People think that it's a great language, but not many people really want to work with it, right? And that got me thinking, why is this the case at all? So I think that really, like, the conception around Swift is it's for Apple devices. And when I say for, I mean you can only build Swift apps on Apple devices, and you can only build Swift apps for Apple devices, right? Well, the thing is, that isn't exactly true, because Swift.org, for example, says that Swift is intended for any platform. The GitHub of Swift says it's intended for any platform. It's a systems language. And Chris Latner had also said this in 2017. He was like, my goal for Swift is world domination. We're not quite there yet, but that's the plan, right? So the plan for this talk is to look at some myths that people believe about Swift, and that it's kind of very easy to fall into. And then we're going to look at the reality of the situation. And along the way, we're going to learn some really fun theory about compilers and cross-compilation and all of that fun stuff. So let's start. Myth number 1. Xcode is the only decent way to build Swift code. Now, most of us here use Xcode. Most of us just hit Command B or hit that build and run button, right? And there isn't particularly any reason for a lot of us to go outside of that, which is kind of something that I want to motivate in this talk. But first, I want to show you that it is easy to build Swift code outside of Xcode. And the way that we do this is with Swift PM. So again, using Xcode, we've all dealt with Swift PM when we're adding dependencies or just like configuring our targets and things like that. Well, SwiftPM actually has this amazing command line tool, and you just run. So there's a few steps here, right? You just create your package using Swift package init. You build it, and you can just run the executable directly from there, right? OK, so that brings us to the next myth, which is, I mean, OK, sure, you can build Swift code outside of Xcode, but can you edit Swift code in a good way outside of Xcode? Nobody wants to be using text edit, right? Well, OK, so there's this thing called SourceKit LSP. And this is a great open source project. It's by Apple again. And it basically gives all of your IDEs Swift superpowers. So for example, in VS Code, you can install the Swift extension, which is it's run by Apple pretty much, and the Swift server workgroup. And with this extension, you get like full capabilities to build, run, edit inside of VS Code. But beyond that, it's not just about VS Code, because it implements the language server protocol. Anything that supports LSP, such as Sublime Text, works with it as well. If you do have Stockholm Syndrome, you can also use Vim. I'm not going to judge you. But it's pretty cool, right? OK, now we have the tools to edit and build Swift code on macOS without Xcode. But can we do this on other platforms as well? As it turns out, we can. So you can build Swift code on Linux. This is Ubuntu, writing the exact same Swift project. You can do it on Windows as well. And this, if you have a jailbroken iPhone 5 from 2012, if you have a jailbroken iPhone at all, you can also write Swift code on that. Don't ask me why you would do that. But I think the point here is not so much that you can code on your phone. It's that Swift supports so many platforms that we don't even think of a compiler supporting. I mean, it supports jailed iOS as well if you see Swift Playgrounds. And I think there's some projects to put App Store-friendly Swift compilers out there for like iPhone and things like that. So yeah, OK, we can build Swift code on Linux and Windows and iPhone, right? What do you build on those platforms? One common thing that a lot of people build is they will build backends. And this is great. There's some projects, there's Vapor. There's a super strong Swift server workgroup. And people are building some amazing stuff with Swift. I know that even at Apple, they have some of their backend infrastructure written in Swift, which is super cool. But beyond that, you can actually build consumer apps with Swift as well. So here's an example, which is Arc Browser. This is a web browser. It's kind of been making the rounds recently. It's super popular on macOS these days. They're building their Windows app in pure Swift. How cool is that? This is, I know that it's a little bit dark there. I don't know if you can see that, but that's declarative WinUI with Swift. And beyond that, you can also do the same thing on Linux. So this is an example of a GTK app built in Swift. This is actually cross-platform code. So this same GTK app would run on Linux, it would run on Windows, and it would run on macOS as well. And it's actually pretty easy to distribute these too. So it used to be harder, but now you just pass this flag, which is static Swift stdlib. And you get this executable. You can share it with anyone, and they can just run it. The one problem with this, though, is that the files are slightly large. So you do end up with a bit of bloat. That's something that we used to see on iOS as well before ABI stability. But hey, at least it's not Electron. All right, let's have it. Yeah, OK, now we're getting on to the fun stuff, OK? This is, I think, where the interesting stuff starts, which is people believe that you can only build Swift code for your own platform. And who's building Windows apps on Linux or Linux apps on Windows, right? But in fact, there's this whole world of things called cross-compilation. And us, as iOS developers, we do this every single day. When we're building a Mac app, when we're building an app on macOS, for example, anytime you select iOS as a destination, it's doing cross-compilation. And this is actually super, super powerful. It's not just limited to running on macOS and building for iPhone or Apple Watch, for example. And I want to actually have a brief interlude here. Let's look at some theory, okay? So when you're compiling Swift apps, typically what you do is you take your Swift files, you pass them through the Swift compiler. There's some intermediate steps in that, but you get out this compiled app and you run it on your machine, right? This is kind of what I showed as well on the Linux and Windows demos. With cross-compilation, what you're doing is you're producing an executable that is targeting a different platform. So here we have this terminology. We have a host machine and a target machine. And the host is where you're doing the building, and the target is where you're doing the running. Here, we're building on the macOS host, and we're building for the iOS target. And the other thing that's needed here is, so you give the Swift compiler this SDK, which has like headers and other different information about your target platform. But in essence, that's basically all you need to do with a lot of asterisks. But you give your Swift compiler this iOS SDK on your Mac, and it builds you an iOS app. So yeah, Swift is a cross-compiler. As it turns out, Swift PM is also a cross-compiler. So this is not just about Xcode. Again, here we have this thing called an artifact bundle, which basically contains an SDK. We install it into Swift PM, and we run Swift build with that SDK. We get out a Linux app, and we can run it on Linux. So this is kind of work in progress right now. And some of the stuff I'm going to show you in this talk is also built on this. But this proposal has landed and has been approved. So you're going to probably see it land within the Swift toolchain very soon. Yeah, so this is basically cross-compilation from a macOS host onto a Linux target. And that brings me to the next thing. Now, this is a slight tangent from, I know that a lot of this talk is based on talking about iOS and macOS and Linux and Windows. But I really want to show some of the other cool stuff that you can do with Swift as well. So you can actually target lots of other platforms. And here's an example, right? So this is Readdle, and they make Spark Mail for Android. They also make Spark Mail for Windows. Both of these are based on Swift code bases. So yeah, that's one example. Another example is embedded or bare metal. So there's this company called Mad Machine that makes hardware boards on which you can run Swift code. You can also do this with, and this isn't mentioned in the slides, but you can also do this with a Raspberry Pi. There's also like some projects out there to support cross-compilation for Arduino. So if you're making a hardware project, maybe Swift is a good language for your next one. Finally, if you're using macOS 9, I don't know why you would use macOS 9 again, but just to show that it can be done, Jordan Rose, who used to work at Apple, he built this toolchain where you can actually compile Swift code for macOS 9. Just super cool stuff. And another example, and this one's really taking off these days, is so WebAssembly is this platform which basically runs inside of the user's web browser. And with Swift compiling for WebAssembly, there's this project called Tokamak that allows you to take your existing Swift UI code and make it compile for WebAssembly, and you can have Swift UI running in the web browser. So we can share some of that Swift UI love with other people. And another slight tangent here, but again something super cool, is cross-platform Swift. So when you're building cross-platform apps, right, a lot of people will choose languages like or frameworks like Electron or something Rust-based, for example. And okay, that's a good choice for some cross-platform needs. But the cool thing about this is you don't have to be limited to just using one particular framework. So if you're building an Electron app even, right, you can actually use Swift inside of Electron. And Swift, the reason that this is possible is because Swift has these great interoperability capabilities. So it can interoperate with C, Rust, Python, Kotlin, C++. It can interoperate with JavaScript. This is JavaScript Kit for WebAssembly. It can interoperate with JavaScript. This is JavaScript Core. It can interoperate with JavaScript. This is Node.js. So, I mean, yeah, there's a lot of JavaScript in here, but JavaScript is super popular. And if you're using Electron, for example, you can actually include Swift code. Now, why would you want to do this? So here's a library that I was working on at this place called Texts, right? Text is, just for some context, they're a messaging client, and they support all of these different messaging platforms. And most of that code is written in JavaScript. This is actually an Electron app. But we wanted to include some functionality that we couldn't just get out of JavaScript. So for example, on the macOS version of Texts, we wanted to include support for rich push notifications. Another thing we wanted to do is we wanted to talk to some platforms that have very specific APIs that, for example, simply you can't interact with them using Electron because, for example, they have specific TLS ciphers. So we realized that Swift Neo actually supports this. And we built a Swift component of Texts with Swift Neo. And we have some bridging here. This is using the new Swift 5.9 macros, which are an amazing feature, by the way. You can declare node classes in Swift. And you can use these on the other side in the JS world. And that allows you to sprinkle in some additional functionality that you wouldn't get normally. This is actually also, we're planning to use this to target Linux as well. So it's not just like you can use this on macOS. There's a lot of things that you can do with Swift that you really wouldn't think about oftentimes. So we've looked at a lot of components so far, right? We've looked at things like building for Windows, Linux, and we've looked at hosts and targets and things like that. Now, we have all of these tools in our tool belt, right? What is stopping us from using a Linux host and targeting macOS? Nothing, it turns out. So here's some more theory first. This is kind of the diagram that I showed earlier with cross-compilation. There's one bit that I didn't mention, which is that you also need this tool set. So this allows the Swift compiler to speak any arbitrary OS's binary. It can basically compile for that binary format, right? So in this case, you give it a Darwin tool set, and it can build a macO file, which runs on macOS. It turns out this is all you need. And here's some slides showing that. So first, we have this Swift project running on Linux, or building on Linux. I don't know how clearly you can see that. I think it's fine, yeah. So we installed this Darwin artifact bundle, which is an SDK that I created for macOS. We build, we copy it over to a Mac, and there you go. That's Hello World running on macOS, built completely on Linux. All right? Thank you. So far, so good. But can we take it a step further? Can we do Linux to iOS compilation, no Mac required? We can. There's another step here, actually. There's actually a few more steps. So, I mean, the common conception around iOS is that a lot of the tooling is proprietary. And this is true to an extent, right? This is true to the extent that they have proprietary tools for installation and for code signing. Some of it is open source, but it's kind of difficult to compile. The good news is that there is actually open source tooling available for all of this. So there are a few components that I introduced here, but let's just look at them step by step. So number one, the other thing that you have to do on iOS beyond simply building the app is signing it. And those of you who've been around for a while probably know all of the pains of generating your provisioning profiles and identities and things like that. Well, it turns out that you can actually do all of this on Linux as well. You can sign on Linux. You get your signed app. Now, how do you install this? There's a great tool called libiMobileDevice, which is open source, again. And they basically reverse engineer the entire communication stack. And this allows you to take your app, put it right onto your phone, just like that. So at the moment, everyone's probably a bit frazzled. There's so much theory here, and I just really want to emphasize that the point of all of this isn't really that you need to understand the intricacies of linking and code signing. It's to show you what is possible here in the first place. But let's look at something fun. Let's take a look at a live demo. So yeah, OK. I am just going to switch over to a different display. Just 1 second. And gonna need a minute just to get all of this set up properly. If you think that Murphy's Law applies when you're building presentations on macOS, try to run a Linux VM at the same time with like 3 different USB connections. But the good news is I think we are ready to go now. All right. So I have 2 different things here. Number 1 is a Linux VM. The only reason I am using a VM and not an actual Linux machine is because I would not dare to test the laws of Murphy that badly. And here we are, the first little hiccup. Let's just get this display to scale correctly. OK. I think we're good. So I'm going to do something here. I'm going to screen share from my iPhone by joining a Zoom meeting that I just created. Yeah, I think if this actually works, it might be more impressive than the tech demo itself. And are we in? We are in. OK. And now I am going to thank you for the patience while we're going through this. OK, so we have the iPhone here, and we have this here. Now, this is a Swift package, right? And this is kind of similar to the one that I was showing on macOS. So we have basically just a Swift UI app. Thanks to like the @main attribute, it actually becomes really easy to build Swift UI apps anywhere. This is all that's required in the package.swift. It's just an executable target. And it's a basic hello world, right? Now, I just want you to ignore the fact that this is running inside macOS. This is all actually connected through Linux itself, the USB devices on the Linux machine. So the first thing I'm going to do is run make. And this is a make file that I've got. It's just so that I don't have to type out these commands myself. I am hoping to kind of build this into something of somewhat of open source tooling that would make all of this super easy for everyone to do. But it's going to build. And the first time it builds, it's a little bit slow because it's actually compiling the iOS SDK in addition to compiling the app because it's not pre-compiled on Linux. And one thing that you do realize when you're building this sort of thing is how many moving parts there are inside of Xcode. So every time something inside of Xcode breaks, at this point, I am just surprised that everything else isn't broken as well. But here we are, right? And we just built this project. And I'm going to reload this real quick now that we've built. And I want to show you something, firstly. This is not a toy, right? We have SourceKit LSP with syntax highlighting and semantic highlighting. You can see that this is an enum. So this is in blue, and this is in lighter blue, because this is a static var. Just crazy things like that are supported out of the box. Anyway, now that I've built, you can see that this file inside of here is, this my app is right here. I am going to run make bundle. You can see all of the commands that are being run here, by the way. This just creates this .app. And a .app, if you didn't know this, is just a folder. And it has the info plist file, and it has your executable as well. The info plist is right here, just super simple. I'm going to sign. So we copy this embedded provisioning profile into this directory, and we run LDID on it. On macOS, it would just be code sign. And we are going to install. I'm going to make sure that my display is still live. And I am going to run make install. And let's give it a sec. There we go. That is an iPhone app building on Linux. I want to show you a few more horrible things. So I just checked out a branch called obj-c, and a few of you are already trembling in fear. So am I. But this is an Objective-C app. Can you write Objective-C code on Linux? I mean, most people wouldn't think that this is possible. Most people wouldn't even think about this sort of thing. But this is the sort of thing that we have been doing in the jailbreak community since 2007, before the App Store existed. So it's pretty cool that you can do this. But here's an Objective-C app, and I'm going to do the same thing. I just have a shortcut here called make do that does all of this for me. It just installed it for me again. That is the reaction I assume everyone has right now. And finally, I am going to check out another project. So this one is basically the same as the Hello World, except now you can see that I added a nice little dependency called confetti SwiftUI. This is just a cute example that I found that I liked. And if we make again, let's give it a sec. This kind of sucks. You do have to reload to get the dependencies to load. But yeah, I mean, it knows about the dependency. That works with SourceKit. I can install that. And now when I click on this, there we go. So pretty much anything that you can run on, like with SwiftPM on a Mac, I'm just trying to show you here that you can run it in a Linux machine as well. And you know, again, like iOS is just one example that I wanted to show here. More than that, it's about just the versatility of things, right? So can we just switch back to having an extended display as well? OK, let's just. All right, I think we're good to go. OK, that was a demo. Now, just as a bonus here, I want to show you that you can also debug with LLDB. So this is, there's a little bit of theory here. This is basically, if you're debugging a remote target with LLDB, you run an LLDB server on the target, and you run LLDB on the host. That's kind of what we're doing here. We're just like another step with the libi mobile device stuff. But yeah, I mean, you just press F5 in VS Code. It starts your debugging session for you. Here I set a breakpoint on print. And the moment I click on that, it triggers a breakpoint. But yeah, so just to like wrap things up, right? In conclusion, let's call back to where we started, which was we were looking at why Swift isn't more prevalent in other ecosystems. And Chris Latner said that he wanted world domination. I think a lot of us would like world domination because it's a rising tide. The more we build for Swift, the more code there is out there, the more robust our tooling and our ecosystem becomes. So there's 3 steps to it, really. Number 1, you got to solve technical problems. And when you want to target other platforms, it is sometimes hard, to make sure that all of these platform matrices and configurations work. The good news, and what I hope to have shown you in this presentation, is that this is mostly done, right? Swift is super versatile. If there's little holes out there, they're being filled. You can actually join and help fill them as well. But this is done. The next two steps, though, are prioritization and building. So prioritization really is about, it's a people problem, right? We need to start to build Swift code for other platforms. We need to start to build Swift code on other platforms and improve the tooling. And then we actually need to build good projects. So that's my call to action out here is let's just get out there and build something great. Thank you.